Hey everyone, in this video I'm going to be showing how to recycle gold from old computer parts. The computer part I'm going to be using is an old CPU that I found in a computer from a local elementary school that was in a dumpster. So, I took the CPU out. You can see I've already done this on it once, so it's already broken up. Anyway, what we're going to be taking the gold off of is the pins and the gold inside of the CPU. And we're going to be doing this first with a mixture of hydrochloric acid and nitric acid called Aqua Regia, or Aqua Regia. There's different ways to pronounce it. And the reason it dissolves gold is because nitric acid actually does dissolve gold, but only at a small equilibrium. So when hydrochloric acid is added, the chloride ions attack the auric ions, the gold 3+ ions, when the nitric acid pulls them off to form the chloro-auric ion. And because that can't go back to form gold, it drives the equilibrium forward and dissolves the gold. So Aqua Regia is a 3-to-1 mixture, so 1 part nitric acid to 3 parts hydrochloric acid. So I'm going to be adding that to the speaker and showing you the reaction once it gets started. So here you can see the pins of the CPU bubbling in the acid solution. I put a watch glass on top of the beaker because it can splatter a little bit. Anyway, so let this sit until it stops bubbling, however long that takes. It might vary. Okay, the reaction is proceeding pretty rapidly now. I put a watch glass on top of the beaker in case anything splatters out. It's producing a little bit of nitrogen dioxide, and you can see the bubbling is going pretty fast. If you look closely, you might be able to see the pins bubbling a little bit in the acid solution. Anyway, so let this react for however long it takes for it to stop bubbling. It varies depending on how much gold is in there. And once that's done, decant the solution into another beaker to leave behind all the other CPU parts. And you'll be left with a solution of chloro-auric acid. Right. Okay, the reaction is finished. So now decant the solution into another beaker to leave behind all of the other computer components and unreacted materials. And now what you have is a solution of chloro-auric acid. Now I couldn't find much information on the internet of how to go from chloro-auric acid to gold, so I developed this part myself. And what I did is add a few pieces of magnesium into here, and I'm not exactly sure what the reaction is, but it displaces the gold, and the magnesium goes into solution and you precipitate out a fine gold powder. So I'll add the magnesium and show you what the reaction looks like. Alright, I've got some magnesium from some magnesium ribbon, and I'm dropping it in the solution. You can see at first it fizzes really rapidly, and this is because there's leftover nitric acid and hydrochloric acid, and that dissolves magnesium really rapidly. You might want to be careful because some nitrogen dioxide gas will be produced. But after all the nitric acid and hydrochloric acid is consumed, then the chloro-auric acid will start to work on the magnesium. So I'm going to go ahead and get rid of the rest of the nitric acid and hydrochloric acid, and then show you that reaction. Alright, now that the reaction between magnesium and the leftover acids is done, you can see what the reaction between chloro-auric acid and magnesium looks like. It's a lot slower, and you can see a precipitate of gold particles. And that's going to be our source of gold after this reaction finishes. Anyway, the beaker's getting really hot from the reaction between the leftover acids and the magnesium, so just let it sit, keep adding magnesium until the reaction finishes. It might take a while though, hours, so give it a while. Now the reaction is done between the magnesium and the chloro-auric acid. So filter your gold slurry and let it dry and collect the gold particles. So here's the gold powder I collected after filtering. You can see I have quite a bit. Now I need to melt it into one piece. That's going to be the harder part because gold melts at about 1000 degrees Celsius. So I'm going to be trying with this stainless steel measuring cup crucible, which should melt at about 1500 degrees Celsius, and a propylene torch. So I don't know how well this is going to work though, because it might be hard to melt the gold, but I will show you the results of me trying to cast it. So now I'm trying to melt the gold with my little red-necked blast furnace. I'm using my propylene torch and silica crucible. The stainless steel cup wasn't hot enough. I'm smelling a little bit of nitrogen dioxide, which I think is the decomposition product of the impurity magnesium nitrate. So you need to be sure to be really thorough on the filtering and washing to get out all the soluble impurities, because I think that's what's left over. Anyway, so hopefully I'll be able to melt it with the setup, and I'll let you know when I do. Alright, unfortunately I wasn't able to melt the gold with my current setup. I have in the past built a really hot blast furnace that I know would have melted this, but it is at this point non-functional. So I wasn't able to melt the gold, so I didn't get the finished product I was looking for, which was a small shiny bead of gold. But I'd encourage you to try this process if you have a metal forge or a blast furnace. It will melt gold, and please show me your results. Thank you.